So let's talk about some of the technology. The key thing here is that the IT, OT issue also requires how the business unit goes. Business units are really important in the utility and in the city. What those mean for us is that that's power production, that's power trading, that's energy scheduling management. We also have a business unit that sells telecom services using transit internet support that we sell to the large media companies so that they have large connections to the internet between their centers. So all those business units have a need for both IT and OT structure. The OT structure is probably the oldest one that we've got. The OT for us as a city of Burbank, police and fire and electric and water utilities are the key ones that have been using OT technology. We put all that under the utility about 20 years ago so that we help the police and fire with their 911 and response stuff and their mobile apps that they use to keep the field informed and how they need to contact both when our forces go into Glendale and Burbank, so we have regional communications. Those things have all been an OT function that's been handled by our OT people since 1991. The things that I think that differentiate OT from IT is telecom is more tightly done inside OT. By that I mean radios, the 911 functions, things that are more electrical engineering oriented than they are IT, and some of the things back when the public switch telephone network was more of a key thing. The time response associated with the 24 hours as well as the latency issues are another thing that starts getting more electrical engineering like. Then the same thing with the security. To understand the security, you quite often have to understand how intermod, man-made interference, and natural interference can affect your radio systems, because it isn't just the cybersecurity, it's the complete security of your system. Plus we face the issues here as a public agency for public access and transparency. Putting together this stuff, it was one thing when we were doing the power plants, we had to really increase our project management skills. We found that when we moved to these higher level of technologies, the need for stronger project management got an order of magnitude even stronger. It is amazing how much these projects are very much like making sausage. You do not want to see how it's done. It would scare you, but you have to go through, you have to solve those cases in real time, and you have to make up for them. We use the use cases. The use case analysis is really great. I mean, we've gone through this approach, even though, as messy as I told you, we seldom go over budget. We might slip a while, but we don't slip much. This project on integrated ADS is about 5 months behind, but it's on target financially, and I'd rather have a little bit of time go to make the thing right than I would to go over budget. We have structured our solutions from generation to the customer. We realize that some of this stuff, when we do the architecture, we've had to make some judgment calls. But the key thing is it's a tight integration with power resources. Again, affordability, sustainability, and reliability is so important. And we want to tie together all of these operational things. And in the process, one of the things that we put in here that I think is a good thing is that we keep track of our uncertainty as well as our savings. This device will also post how much did we save using the smart grid than if we would have just used the old ordered method. This is an overview of the basic architecture that we have, so you can see how this ties back. We use an enterprise service bus, and we do also then have our firewalls, but we also have this communication infrastructure. The communication infrastructure, which is our fiber network and our radio system, that's an important feature to how to tie things together. That is unusually fast. We have response across that network of right now is measured faster than 10 milliseconds. So that's a very high-speed system.
Thank you very much. That was Fred Fletcher of Burbank Water and Power on the topic of best practices for IT-OT convergence. And we got a question here from Scott. Actually, there's a couple related questions. So, Fred, the best way to address the fear from the OT side relating to these emerging IT technologies, IP networking, virtualization, etc. And a related question, which IT-OT aspects are appropriate for the cloud?
Our OT people understand IP networking very well. We have some IP people those kind of engineers already in the OT. They talk, they explain to their fellow workers, and we didn't have any problem, but we did get modern, intelligent electrical engineers to understand that technology right from the beginning.
Terrific. Well, Tim wants to know, how did you specify the communications equipment, the network management, et cetera? Did IT spec it? Did OT spec it? Did one of your suppliers help you specify it?
OT spec'd it. We have a very strong telecom side.
Okay. Well, so Bill asks, what happens to SCADA and OMS when a storm or an earthquake brings down this sort of standard communications paths, especially, the LAN infrastructure?
We have it pretty well hardened. Our systems, we could take several hits, and we have different levels where we back to. So we've got primary and secondary fiber, and we have wireless mesh.
Terrific. And Barrett wants to know, what about weather forecasting? Where does that come into this picture?
Oh, weather forecasting comes into this picture with regard to predicting your solar and predicting your wind. You need to know both in order to protect your wind, and not just where you're locally served, but wherever your wind generators are or your solar generators.
And in that sort of slide you showed with your different systems, where does it flow in?
It flows in from Schneider into the SCADA system, which feeds into the web distribute.
Terrific. And finally, one more, and Renee asks, is geospatial critical to data analytics? And maybe, Jeff or John wants to jump in here as well.
Yes, it is critical.
Any color on that from John or Jeff, either one?
Go ahead, Jeff. Go ahead.
Oh, actually, John, you start.
Okay. I would just say absolutely critical. Every project we've had has used a geospatial component, even just to determine the distance between devices for a voltage drop, for example. Oftentimes we produce and use schematics from that, but the geospatial component is very important. Go ahead, Jeff.
Yeah, Jesse, this is what we often refer to as a single version of the truth. And I think today, in the spirit of better IT, one of the things that has certainly gotten better is geospatial technology. So it really is possible. Fred is living proof, in fact. It really is possible to get that system of record for network topology and asset in the geospatial context to make that work for you across your workflow and build a single integrated model that you can use to share really across all those operational systems.
Terrific. So we've heard already from Jeff Meyer at Schneider-Electric, but he's going to mention a few really key takeaways before we wrap up. So Jeff, take us home.
Okay, so I think we've heard throughout that we're well on our way to an IT-OT converged world. And I think that really means that while IT may be getting more mission critical and OT may be getting more smart and more integrated and more pervasive in our networks, one of the days coming when it will be hard to draw such a complete distinction between IT and OT, and they will all those technologies will be smarter, will be more integrated, will be pervasive, and will be mission critical. So we talked a bit about the opportunity to align the operational technology and its applications with the key smart grid business drivers. Try to remember that sort of sundial-looking thing and put that in the context of Fred's excellent talk about those things which were important to the vertically integrated utility of Burbank. So things like improving use of integrated renewables and managing the distribution and generation technologies in a more efficient way, lowering the cost and improving reliability. Those are things to think about in the context of new OT. Lastly, I would remind you that there are challenges. Complexity of all that new technology and all that smarter technology, I think, brings the need for better automation, for better tools to help humans manage the grid, and a requirement for that roadmap that John described, which leads us, I hope, to a consistent architecture. And even if it's one that we can't get to completely in the beginning, if we have to take incremental steps to, at least we can take steps in the right direction. And that may mean, and several of the questions pointed to it, that may mean a shift, however slight, in the humans and the people involved in IT-OT convergence. So with that, I'll say thanks again. Thanks to you, Jesse, and your staff, and thanks to all the attendees for listening in. And I think we're going to stay live for a while and take a few more questions.
Yeah, thank you. So we had a question from William, if you could expand on how the transition was made. Maybe, Fred, you could start. What organizational changes, technology or reassignments, that kind of thing? And also, were there any areas of the ITO systems that were intentionally not converged?
We started seeing this problem between IT and OT emerge when we were about 75% through the initial design. That would be back in 2008. We brought in Gardner Group to take a look at this problem, and they helped us a lot recognizing that, and then we also had the support of KEMA on some of these things to help get more into the details of how to break up OT and IT.
Jeff or John, anything to add from your experience with lots of utilities?
Yeah, I would say I've certainly seen a lot of analysis done up front. What do you want to converge and what don't you want to converge? It's interesting about which systems do you want to keep from converging. And that's interesting. You certainly, I think it's still good to have some boundaries around which organization is responsible for which system and what do they do to maintain those systems. But this really is an integration of almost everything you've got going. You know, I just see a blending of all of this data from these systems to come together for SmartGrid.
Matt asks if, Fred, if you've got a dedicated IT architect, and I would ask Jeff or John to chime in and say if you see that frequently at other utilities. But starting with you, Fred.
Okay, we've got a chief technology officer that we brought in, and he and I are kind of like the joint architects of the system. This, what you see, is basically the architecture that he and I have put together.
Okay, terrific. And Jeff or John?
This is Jeff. I think this is one of those human resource kind of shift things, Jesse, that I think we're seeing more and more and are going to continue to see more. Most of the architects that we know at utilities really come from the IT shop, and they're sort of IT architects. So they need to get additional exposure to the operational technology implications and the things that will affect that overall architecture. So, you know, it's sort of a chicken and an egg kind of thing. Are they going to be certainly they're one of the important people to lead that transformation. Will they have all the knowledge necessary, or will they have to be coupled with someone from the operational technology side to help bring that part of it in?
James asked, which team chose your meter data management system, and which team or who is responsible for managing it on a day-to-day basis?
The meter data management system was chosen by the customer service division, but it was strongly influenced by my group as well as the OT people.
Terrific. With that, I think we better wrap it up, and all remains to me is to say thank you very much to Jeff Meyers and John Dirkman of Schneider, to Fred Fletcher of Burbank Water and Power, and thanks to all of you as well, and hope to see you again here soon at our next SmartGrid News webinar. Thank you.